So let me just arrange my desktop here. Right. So I did some slides just to try and help make me think about what we're talking about here. So one of the first projects I put together was with MicroPython is something I call PieChart. And I think you covered this a couple of months ago. And the idea is it's a tiny little library for displaying, log data from whatever kind of sensor that you've got, all kinds of different purposes that you could use this for. And when I was doing this, I was originally just thinking, just put in a chart on a little screen. And then I thought, well, I can probably do better than that. I can probably make it be a dashboard and have several different tiles of different types on a screen. So I sort of knocked together this very small framework. It's not been very thoroughly tested, but it does work. And you can do things like put an image on there, so you can see on there, there's a little picture of me. There's a little temperature bar chart. You can have the little values at the top of the bar chart. You can have a card where it just shows the value in the middle of the card and that kind of thing. You can customize this, change all the colors, have borders, all that kind of stuff, have rows or columns or however you want it to work. And obviously it works entirely in pure MicroPython. So that's the kind of thing that I like to work on, where I'll think of something that I need, I'll build it very quickly in MicroPython, and then I'll be thinking about what can I then extend that to, and also how can I explain this to my audience of people who, just like me, hobbyists who want to sort of do things interesting. So I'll show you the next one, which is a typical kind of project that I would do. So this is a big mouth Billy bass fish. So these were quite popular in the 90s. Apparently the Queen had one in Balmoral on her piano, was the rumor. And this was a project I put together when the Pico W was launched. So that brought along to the Pico anyway, Wi-Fi. So I know ESP32 and Pi boards probably had Wi-Fi for a very long time, but in the Raspberry Pi community, this was quite a big game changer. So there was loads of projects kicking around about how to light up an LED using MicroPython and a web page. And I thought we can do better than just lighting up an LED. Surely we can make something a bit more interactive, a bit more fun. So what I decided to do was some crazy things. I registered Big Mouth Pico as a web domain name. I then created a little web page, a little API using pure MicroPython and sockets at the time. I've since refactored this using Pimrone's Few library. And I made it so that you could interactively make this robot do things over the internet. And it gets a couple of hits per day. I'll actually show you that now. Let me just head over to mouthpi.co. So this is the live website here. And there's a couple of buttons at the top of the screen there. And this is running on a microcontroller. This is nuts. This is a full web page with a little API running over the internet. So it tells you what the current state is. His head is in, his mouth is closed, and his tail is in. And the page has currently had 492 views, and it's been, I think I rebooted it at the beginning of the week. Occasionally it falls over, but so if I click on the open mouth button there, we'll then get an updated thing, and there you go. His mouth is now open. We can, move his head out, and you can see his head sort of moved out now. We can close his mouth. Now, there's a bit of a cheat going on here because I've essentially just taken 8 pictures of the various different states that it can be in, and the states are sort of down here. But if I plug the power in, it's just in the corner of the room over there. I'll hear that moving all day. So I've just sort of unplugged it a little bit. But this is a live website running on a Pico, running MicroPython. I just find it absolutely nuts that you can do this kind of thing. With microcontrollers, they're not designed for that kind of thing, but hey, you can do it, so why not? So that was me just sort of going one step further and showing people that you can, do more than just put an LED on and off. You can do more than sort of home automation type stuff. So what else do I need to say about that? Have a play with that. One of the cool features that we baked into this, I baked into this, was it grabbed the current time off a network time provider and make sure that that web page has got the correct time when it boots up. Again, because we've got connectivity to the internet, we can do all kinds of crazy things now. That MicroPython library that Pimrone created, they actually created it for their Enviro range of products. I think I've got one just here, which is like a little indoor sensor that can do temperature and all that. And it basically just has a Pico W on the back. They created this entire library, so you can create access points, you can create web pages, you can do templated web pages, a bit like Flask, and you can do logging as well. You you can do that all on using MicroPython on a tiny little microcontroller. So the number of projects, you know, my mind boggled with what you could do with that. So the next one I was working on was a simple robot arm. So I've got this on the desk next to me. I've not actually got it plugged in, but I've got it just here. And you can see the size of it. It's actually plugged into another Pimroni device, which has got a Pico W on board. They call that their inventor. And they have some nice headers there for the servos. It's also got some other features on there too. But the idea here was I wanted to create something that, like a robot arm, you could control again over a web page connected to your local Wi-Fi network, and you could basically just use like sliders, little range sliders, just created using some very simple HTML and a kind of an API. So when you slide one of the sliders and let go, there's a JavaScript on-change event that then just fires off to the back end and just says that slider for the wrist or the arm or the elbow has been changed to this value. And it just means you can then interactively make this robot arm grab things and move it over a web page, which I thought was quite fun. And these are very quick to print, very cheap to print, and they use quite cheap servos. So you can create your own robot arm very cheaply. And it would actually work on a regular Pico. You probably just need to solder some servo signal pins and provide the 5 volts from the Pico. So that was another example. And that time, so each time I create a project, I'm thinking of a number of different things. I'm thinking, how can I achieve this first of all? So there's the sort of overall project idea. How can I communicate this to people on YouTube? Because that's what I like making content about. And that can be quite challenging sometimes if it's a complicated idea. Things like inverse kinematic can be quite difficult to explain if people don't understand trigonometry and things like that. So, you've got to think in your mind who you're actually aiming this at, and you need to break that project into a number of different parts. So sometimes I will just sort of work my way up to a particular project and just work on little bits at a time. So I might just work on the web page one week, and then the next week servo, control, and then the other week maybe some MicroPython code just to bring all that together in a class or something. So that was the robot arm project. One that I've done most recently is what I call Burgerbot. I've got a number of iterations of Burgerbot, and this started out as just a very simple, cheap, round robot, sort of a puck-like shape, and it's got the Pico. This is a Pico W. I think I originally started with just a regular Pico, and you just plug a cable in and have this sort of tethered around, and it's got a little pack on the back there. This is a Pimroni motor pack. I use quite a lot of Pimroni stuff because they're based in the UK, and it's quite cheap for me to get hold of them parts. And I now work with them doing some of the intro videos to their products. So you might see me on their web pages as well. Anyway, this Burgerbot. So what I wanted to do on this one was take the robot, take the code for moving it around, and it's very, very crude. Forward, backwards, left, and right, just moving 2 motors. So conceptually very simple. And I wanted to create a pen mechanism that we could make it draw, a bit like the old logo, if everybody remembers logo back in the day, or turtle graphics. This would be great for education to teach some simple programming concepts. So I thought, how can we physically make this? So I did the Fusion 360 design. There's a couple of different ways I could do the pen mechanism, and I wanted it to be as elegant as possible. So one of the shows, I think it was last week's show, I was talking about if I put the pen on the very back of the robot, when that rotates round, it will actually draw like an arc. Whereas if I put the pen directly in the middle between the 2 motors, when it rotates around, that pen stylus will be exactly in the same point. And it means we can then make it draw pictures, write text, whatever we want to do, just by sitting on the paper and drawing. So that meant that I had to completely redesign the Burgerbot by moving everything out of the way, putting the pen right in the middle of the robot, and then coming up with some kind of mechanism that can lift it and lower it reliably using some very cheap parts. And I went with this sort of rack and pinion type mechanism. So it's really fun, really elegant, and it just works. So this was a new feature. Then what I wanted to do is I wanted to make that, somebody reached out to me and said, I would love to have this in a sort of education environment, but we have restrictions on Wi-Fi. And I thought, well, we can make this an access point. This is not a problem. Each robot can be its own access point. You can connect to that with a phone or a tablet or a computer. and then you can control it. You don't have to worry about other access points. You can only connect one device, I think, at a time on the Pico version of MicroPython anyway. And that's ideal. So I created a very simple web page using that technique that I'd developed for the robot arm. And that meant that we could then make the robot go forwards, backwards, left and right, move the pen up and down, all from a web page, but also have it host that via its own access point. So that was a bit of a stretch for me just to build that initially, but now I've got that, that can be another step that I then use for future projects. So that was Burgerbot. That's one of my favorite projects right now. Then sometimes I do projects just because I think of the idea and I think, how can I make this happen? So this is the RGB LED Dog Coat. I thought it'd be quite a fun project to do for a number of different reasons. So I've got the sort of smart saddle here. So this sits on my little Chihuahua. You can see there's Archie. And it has quite a few, it's got two RP2040 devices on board. So I just press that little power button there. There's a little battery pack there. There's a little LiPo battery charger and power output. We have a Pico W there, and we have the Plasma 2040. So this is a device that Pimoroni created specifically for lighting RGB LED strips. So it can manage all the clever power management stuff. It's got some nice big chunky cables there, so you can plug the things in. And it's also got some user buttons as well. And then what I then did was just bridge between the Pico W and the Plasma 2040 over a simple UART. I created a library called EasyComms just to make that really reliable. And that means that we can have Wi-Fi, because this doesn't have Wi-Fi in it, and then do the access point that we've learned from the Burgerbot and from the simple robot arm, and then scroll text or change the color patterns, all from your phone while you're walking your dog. So this is a really silly but fun project. And really the design challenge were probably things that weren't to do with robotics or MicroPython. They were like, how would you just attach something safely to a dog without it falling off or without it snapping or breaking when they shake? But yeah, it's quite a very simple sort of arch shape with all the different devices that are sort of stuck on there with some screws. So this is going to be in the Magpie magazine, I believe, next month. I think they're going to do some articles on it too. So that was a really fun one to do. And what I actually liked about this one was RGB LEDs are so much fun, and they're so easy to get working with MicroPython, and the sort of for loops and, changing the color values or cycling them around. It's ideal for sort of just, showing how you can do some very simple programming concepts with that. So absolutely love that. You can also do some complex things like converting RGB to hue saturation value. There's a nice little algorithm for doing that. And I love thinking about complicated problems to do simple things. So scrolling text on RGB LED strips that have been cut out and sort of in a snake shape. So they sort of loop round a bit like a radiator type shape. If you want to create an X and Y coordinate on that, you need a little algorithm that figures out which kind of strip is it. Is it one going up or one going down? Because the numbers will change direction. So again, little programming concepts like that I love to think about. So I've only got a couple more of these to share, and then we can have a look at some of them. So this one is me figuring out how to do things with graphics. So I created this Pico Tama Chibi, and the idea here is it's a bit like the Tamagotchis. I didn't want to get any trouble with any copyrights on YouTube, so I just came up with a silly name for this. And it has one of these very small black and white screens. They have two colored sort of overlays on it. They have like a yellow one at the top, and then they have a blue sort of filter at the bottom. So it looks like it's color, but really it's just one bit. And one bit's great because it means we don't use very much memory to store the bitmaps in there. So lots of frame buffer stuff on this. And I did discover very quickly, if I want to animate those graphics in MicroPython, I will basically run out of memory very quickly. So I was cleverly animating this little poop emoji in the corner, and then I had another one where it's bouncing around and then sort of smell things coming off that, and then I would get these memory errors, and I thought I need to figure out how to do memory management on the Pico in MicroPython. So I made like a little module that could load and unload the different animations, and I would just make sure I'm never using more than one animation at a time, and each animation might only have like 3 or 4, 5 or 6 different frames of animation, and they'll be quite small, like 32 by 32 bit grid. So that was me just trying to figure out how to put something in a small kind of form factor. And I mean, it really is quite crude. It's just a little PCB, and it has a little screen on it, and then underneath there is just this is the original Pico. This doesn't have Wi-Fi, so I could probably return to that one and improve the code on that one a little bit, but that was absolutely tons of fun to do. And the last one I'll show you, this one is a project I created when the Pico W came out. And again, I was playing with the Wi-Fi. I was thinking about what can we do that's fun with Wi-Fi that would be a really fun project to do. And I was thinking, well, we can grab a list of all the Wi-Fi hotspots, we can get the signal strength from those hotspots. And then I was thinking about how can we display that in a really novel way. So I came up with this Ghostbusters Wi-Fi scanner. So if I just press that button there, it should do its reset. So what it will do is it will scan through all the different hotspots in the current area. And then depending on the signal strength, it can move these arms into different positions. So if I just press the sort of up and down buttons on here, when it's working properly, I think the batteries are a little bit flat on this because I've had it in the, let me just switch it off and on again, see if it'll do its powering up. Yeah, so basically there's two little arms in here that will raise and lower depending on what the Wi-Fi signal strength is. But obviously with it being a demo, it's now not wanting to play nicely. So that was a really fun one. There's a nice little mechanism in there that sort of just meshes together. There's just one servo that will power that. There's a nice screen. This is a Pimoroni display pack. So it has quite a few pixels on it and its color. And I created a nice little menu system that you can scroll things. You can probably just about make out there. There's a little red bar that's selected moving up and down. Again, the code for doing that, really fun to create things like that, because you have to start thinking about how would you create that? You know, if that doesn't exist, how would you go about creating that? What's the sequence of, you know, coloring in things and highlighting them and have them at the front, making sure it doesn't go off the top or the bottom. So really fun things like that. So I think that's been in the Magpie magazine as well. And that was quite a recent one. So that's the projects that I had to cover off. I'll just show you on my desk here. I've got a number of different robots that I've been working on. This one was quite a fun one to work with Pimoroni. They launched this Motor 2040 board. Again, it doesn't have Wi-Fi, it's just got the RP2040 on board, but it has these really nice connectors on the side, which, as well as controlling the motors individually, they can get feedback using encoder so that you can very, very precisely move this robot around and know how many cycles, you know, it's spun round. And it has these mechanism wheels on it. So these mechanism wheels mean that it can go sideways as well as backwards and forwards and turn around. And this is just a very, very simple, you know, it's like a flat plate with the motors connected on and the wires wired up. So very, very simple. We've got a little rangefinder that isn't actually plugged in there, but that one is a very, very simple robot, but very fun to do. A robot that I built that doesn't use a Pico, it uses an ESP8266 running MicroPython. This one is called Weatherbot. I'll just take his head off because it always seems to fall off there. And what this one does, if I just go to the overhead there for a second, this one has a servo on board. You can see I purposely left all the wiring on display to show how this works. So the servo will move that little dial on the front and it will show the current temperature that it detects from this DHT11 that's on the side here. So you can see there, very, very simple wiring. And it will also send off the value that it has to my local MQTT server, and then I can graph that with things like Grafana and capture it with InfluxDB using Node-RED. So there's quite a few things we can do with very, very simple components and just some 3D printed designs. And then the smallest MicroPython robot that I've created is this one here. So this one uses the Pimoroni Tiny 2040, and you can see there's a whole mass of wires there, so it's just inside there. So that's the RP2040 on a really small form factor. It has a little H bridge there for controlling the two motors. So there's two N20 motors inside there, and there's also a laser rangefinder on the front there as well, so that it can actually detect the distance in front of it. And this works quite well. The wheels don't grip very well on the floor, which is why I've got these little elastic bands on there, but that's probably the smallest robot I think you could probably get away with using the components that I had available. What else have we got on here that's probably worth talking about? So some other robots. So I noticed you had like was it a Nibble or a Bitly robot walking out before. So this is an Open Cat or Open Bunny. So it's basically an open cat sort of frame, and then I've just changed the head and just changed around some of the circuitry on there. And again, that's using a Pimoroni Servo 2040, because there's a whole bunch of servos that need connecting up there, and it can wiggle his tail and do all kinds of things if I plug that into some power. Let's see if it'll run the code. Put that in. Get it to actually do something. There you go, wiggling his little tail. So again, all in MicroPython. Need to probably upgrade this so that it can work over Wi-Fi as well. And yeah, one of the challenges with that robot is coming up with the walking pattern. So how do you make a robot walk if you've got you know, 4 different servos? You need to come up with some kind of walking cycle. So I did a show about that on YouTube about how I done that. But this doesn't have any kind of IMU. It doesn't know if it's tipping over or anything. It's just going to repeat the same steps and just hope that it's walking properly. So there's some of the projects I've wanted to sort of share with you today. I'm absolutely love with MicroPython. Been using it for a number of years now. Like I said, when the ESP8266, when I discovered that MicroPython was a thing, I was like, I have to use this. I'm not a big fan of Arduino and C, simply because it's quite difficult to sort of teach, and you know, the grammar and everything, it kind of messes up the logic. So MicroPython is ideal for this because it's about as close to plain English as you can get. So that's one of the reasons I absolutely love it. As well as you don't have to wait for it to compile, you can just make it work and see, does your code work instantaneously? So great for people who are very time short. So any questions you want to cover off? I've got a few questions myself I wanted to sort of ask while you guys are here. Let me just bring them up on my screen here. So what do you think about manufacturers such as Adafruit, Pimoroni making their own forks of MicroPython? I was worried that this would fragment possibly MicroPython, or people would go off a bit too much in one direction. I understand why they do that, because if they've got a board that has some very specific features and they want that to be easily programmable and baked in, then that's probably why they've gone about that. I do like the way that CircuitPython has gone, where they're kind of downloadable modules. But things like board.io, they confuse me. I don't use them very often because of that. Whereas Pimoroni, they basically just baked in, and they're having to create separate images for each different type of board they have, because, you know, if you're baking in these libraries, you can't bake everything in. And at some point, you're going to have more products than there is memory on these boards. So, you know, does it fragment the platform in any way? Is there anything in the pipeline that you know you're working on that will bring these closer together, you know, around board specific libraries? So if I grab a CircuitPython library to make a servo work, or some kind of rangefinder, you know, can I get that to work on a regular MicroPython device without, you know, their stuff? That's some of the things, some of the challenges I come up with, because I'll find that there's a library that works on one and then not on another. Some of the other things I was thinking about was, currently, when you download things from PiePy, I don't believe there's any kind of signing going on, so I don't know how secure that is. One of the projects I did a while ago, I think actually before this one, yeah, securing passwords on MicroPython. This was some code I created to obfuscate passwords, and the way that you do this is just use you know, the cross MicroPython compiler, build your MPY file, and if somebody prints that out to a terminal, they can see all the text strings in there. So if you just scramble them with some very simple, you know, obfuscation code, it just makes their job a lot harder, because they can't see that code that does that scrambling and unscrambling. They could probably work it out if they really wanted to, but it just stops the casual person picking up your device and figuring out what your Wi-Fi password is just by plugging it into USB. So that got me thinking about, how can we make MicroPython more secure going forward? Was just one of the things. And then 2 questions. So if you had one wish from hardware manufacturers, what would you want them to build in, or what would you want them to do to make your job as a developer easier? And I guess, you know, you've created your own MicroPython board, so you can ask yourself that question. And then, do you have a particular MicroPython board that you like the best? So Matt, who wants to have a go at answering some of those questions? Nope,
yeah,
can't hear you. You're on mute.
Then you don't tackle the first one.
Yes, can you hear me? Hello?
Hello.
Hello? I'm here.
Yeah, we
Hello.
can hear you.
You can hear me?
Not getting any audio
No,
from anybody
no
at the moment.
feedback. Yes. Kevin, can you hear me? I don't think Kevin can hear me. No? Does anyone?
Yep.
I can't hear.
Kevin, can you hear us?
Can-
No, I can hear Damien fine.
Still not getting any audio from anyone. I don't know if there's an issue there.
Yeah, we can't hear Kevin, but we can hear each other, which is weird.
I can hear people talking now, but I can hear Kevin,
Okay.
but it sounds like Kevin can't hear anyone.
Let's try now. Can you hear now, Daniel?
I can hear you, Matt.
Okay, great. So this is the microphone in the room, really. So I'm not sure Kevin's caught up. Kevin, can you hear us?
Can Kevin see us?
No, I can hear you back.
So he says he can't hear anything back.
I can hear now.
Ah,
You can hear
I can
now?
hear now. Oh, thank goodness.
Hello, Kevin.
Good. Okay.
Hi, Kevin. Can you hear me?
I can hear you now. Yeah, perfect.
Okay. There seems to be quite a delay, but that's okay. I'll try and answer the some of the questions. So yeah, they're all good questions. And yes, the first one, forks of MicroPython, I guess. Yeah, it is an often asked question. What's about CircuitPython, and I didn't know Pimoroni had Pirate Python. I haven't heard that term before, but MicroPython maybe. So I guess you could consider it a bit like Linux distributions, that there's Linux kernel and then there's distributions around that, and the distributions are tailored to different sort of users. CircuitPython targets more beginners, and Python is for industrial users and everyone. But you can think of it like that there are different target audiences, and Pimoroni obviously tries to sell hardware, and they make things smooth for the people who purchase their products. So I think it's good all around a bigger ecosystem with more people involved doing things, and it's good of everyone in this space to have different people working in different ways, and it's good that if we can collaborate and we can not step on each other's toes so much and share work and so on. And I think that happens quite well. We keep as in MicroPython sort of core developers keep in touch with both Adafruit and Pimoroni, which and to make sure that we don't diverge too much in the doing, and touch with what we are doing. So I think it's I think it's the nature of an open source software is that everybody is going to, if it's a good project, people will take it and do things with it. And I definitely would not have wanted it to be closed source just to prevent this kind of thing. That would be, so it's, you kind of choose not choose your poison, but you choose your path. And if you choose closed source, then you can have a walled garden and you can make everything as perfect as possible within that garden, and then everyone has to follow along. But if you have open source, then it's free. It's sort of a free for all sometimes. And so I think it would be good, and we're trying to work towards making drivers more compatible across things. CircuitPython have a lot of drivers, and they've also done work to make them run on MicroPython and other Python-based systems. So there's just a few sort of bits left to do to make it more smooth for the user to say, I just want to use a CircuitPython driver on a MicroPython board.
Yeah.
I mean, I've done this, but I was working with, excuse me, I was working with an infrared camera the other day, and CircuitPython had a driver, and I took it, and within like 5 minutes, I had it working under MicroPython. So that's really good, and I think we can do more. We can do more there to make it a better story, but some of these things are still in their sort of early days as well. And even MicroPython is, even though it's been, I think, 9 years now or more, just over 9 years, we're still sort of developing the core components about package management, which Jim's been working on the past few weeks, and things like that, and still fleshing out API for network devices, and so there's still a lot to do. And by the same token of it being closed versus open source, if we'd waited 5 years to develop MicroPython behind the scenes until it was perfect and everything was all working and then released it, well, that wouldn't have gotten us very far. So it's being an open source project and being immature from the beginning, in the sense of not being finished, has led to people like Python taking it in the direction that they want it for the people, their users, and so on. So I think it's healthy, but also it is good that the different forks keep in touch and make sure that things don't get sort of too out of hand.
Yeah.
So yeah, I think it's a good question, and it's a good question to try and answer, for us all to answer, all the time, and make sure that things, the ecosystem doesn't get too fragmented. I didn't screens go on, and the other questions I've gotten were digitally signing. So microcontrollers themselves sometimes provide ways to protect. The RP2040 I think does, because, for example, you can just take the flash off the RP2040 board and just read it out. So there's always some level, of insecurity there. And no matter if someone has access to the board, then they can, no matter what you've done to try and prevent it, they can always read your password. Unless you have a part that has specific readout protection or something like this, then you can maybe do something there. But that's also actually very hard to do properly and make that everything is secure from end to end. But downloading from PiePy, if you use HTTPS, secure if you trust both sides. Yeah, and if you have a device plugged in via USB and transferring plain text, then that's secure locally. So it's a hard question. It's a hard question to answer comprehensively and make it work. But for a specific application, and all the different ways and things to be, where your weak points will be and where you want this, to prevent people from hacking, and then use the tools available to you to prevent, to make it secure. So yeah, it is more up to the application, I think. How to remember would be just to make microcontrollers that are available. RP2040, when that came out, that was almost like a dream MicroPython. RAM, essentially unlimited flash, and the PIO is a really great peripheral. So the RP2040 was kind of like a if I could make a microcontroller for MicroPython, that's what it would be like. So that would be my answer there. But yeah, I mean, the microcontroller these days are all really MicroPython, enough RAM and enough flash and lots of interesting peripherals. And favorite board, well, I guess I'd have to say Pi boards, because I made, designed and made them. But yeah.
A little biased.
Need to get myself one of those.
It's a powerful. Sorry, you can't buy them anymore because of the microcontroller shortage.
Yeah.
Damon, there's another question in the chat as well.
It's in the chat, sorry. Oh. Did you ever think MicroPython would be used to join Robot Bunny with fluffy tail? Yes, actually. I wouldn't have thought that of outside the realm of possibility. My original reason to make MicroPython was to be able to easily run robots. Yeah, like that's why in the servo class in the STM32 port has been there since day one, and you know, has actually quite a nice class, I think. But
Yes.
yeah, so driving servos was something that it was designed to do. So no, I'm not actually surprised that it can wag a tail.
I just saw you laugh when he showed it off. I thought, yeah.
Yeah, it's cute. I mean, 3D printers, they were only just beginning when MicroPython started as well.
Yeah.
And yeah.
Yeah, for me, that's the sort of perfect intersection of engineering, of software engineering, mechanical engineering, software engineering, and electronical engineering. I love how all of them come together in robotics. It keeps you sort of busy. If you get bored of one thing, or your skills are not as great in one area, you can excel in the other areas as well. Love it.
Kevin, that's what sort of hit me most, was that it's so good to see, you know, one person be able to talk about a bridge, talk about a servo, about MQTT, and then bring it all together, like to see from end to end. And you're like, this thing doesn't exist. How do I make it exist? You know, and it's not like you're on a PC where, you know, most things are just done for you already. You actually have to think about Wi-Fi, and you have to think about connection, and then, you know, the wire doesn't connect properly, and it's like, so you hit real world problems, and you hit memory errors and so on. And I think the constraints of a microcontroller, and also the freedom of being able to do anything from all the way hardware to high-end software is what makes it really, it's really great to see that can just let your imagination run wild, as you obviously do. Desk or from it was good to see all your projects. Thank you.
Yeah, thanks for creating MicroPython. It's one of those things, when I was playing around with the Arduinos, I was like, there's got to be a better way than this. And I hadn't learned Python until about 3 years ago. It was one of the languages I thought I'll have to get into that. I know that the Raspberry Pi was named after Python, and you know, that's their recommended sort of education language. And I thought, well, maybe I need to get into this. And it was one of those like aha moments when I started using it. I was like, why have I been using any other language? This is so easy. Things that would normally be quite complicated to do, like things like list comprehensions, they are so easy and intuitive once you've got around the syntax of it. And the fact that we can now do all that in MicroPython just blows my mind. We can do that on these microcontrollers. It's just amazing. So yeah, as soon as I discovered that this was a thing, I was like, this is happening. I'm ditching all the other code and we're going just over to MicroPython exclusively. So yeah.
Yeah, well, I guess you've seen the light. Or yeah.
Yep.
Very good.
See, there's a question there from Andy. So he says, by the way, KesRobot support myself, generally catching your YouTube replays rather than live. Any plans to push libraries like PieChart to PyPy so that it's simpler to install for others? So absolutely, yes. I have pushed one library. It's just a regular Python library. So I know how to go about doing PyPy stuff. I just haven't got around to it yet. So absolutely, I've got plans to do that. I even created a PieChart GitHub repository just for that purpose. I probably just need to spend a little bit more time. This is the perfectionist in me, just tidying up the code a little bit. Maybe I should just push it as it is and people can raise issues and I can fix them that way. I should be more agile in my thinking.
I gently badgered, and that's a meta joke, the Pimoroni folks to get a few into PyPy to make it a bit easier to consume. So it'd be great to see PieChart in there as well, because I've started your repo and I've just been like, haven't got around to going and getting it myself and playing with it. So
yep. Oh, thank you. Yes. Hi to Phil on from Pimoroni, who's just joined as well. See you there outside. Any other questions anybody wants to ask me about mad robot things? Oops, let's go over to that one there. You can see some of them that are on display. These are some cyber glasses that I created using Pico, so they run MicroPython as well. They can sort of do a fancy little pattern on them. I'm going to be wearing those in Whitby. They have a steampunk fair a couple of times a year, so I'll be wearing them with my RGB LED dog coat. I'll be rocking them, maybe walking around with my Wi-Fi Ghostbusters scanner thing too. But I'll hand back to you, Matt, and I'll listen to more features that have been brought into the main line of MicroPython. Very keen to learn about that.
Well, did anyone have any other questions for Gavin? Or got him here? Andrew wanted to talk about PieChart.
Not really.
There's some discussions recently, I guess, about how to get libraries into or make them more reusable with MicroPython. So PieChart is one of those ways, but we're looking at the manifest option as well. Looking at a few different things, because PieChart doesn't solve all of our problems about getting particular things onto a device. Not quite enough metadata there. There's not quite enough bits and pieces. So
indeed, just this afternoon, Jim and Sarah pushed the first round of the new update to UPIP, which should, and along with some docs or at least examples of how to structure a repo to work with the new sort of UPIPs.
Yep.
So watch this space.
Literally today, yeah. All right. Well, thank you so much, Kevin. That was fantastic. Really, really cool to see all the stuff that's going on.
Thanks for having me.
Yeah, I can see Annie's happening. It's hard to talk about you. Yeah, thank you.
Here as well. See that
In terms of
one
questions for you, Kevin, like the one I had is that I'm always blown away by how slick your videos are, especially because you do it live. Is it
Yes, live
taken
streaming.
much effort to get to that point? Like it must have taken a lot of practice.
Yes,
Maybe
I'll
your
show
lighting
you
is
the.
excellent.
I can show you a shot. This is the studio I'm in. So I've got a couple of lighting things there. I've got some big monitors, some notes as well, so that I can remind myself what I'm talking about. And then I've got the 3D printers. I've got one there. Usually busy printing stuff away. So I've got my nice microphone here. I've got the little Stream Deck, so I can push buttons and move very seamlessly between different scenes. And I've got some software on a Mac. I'm just using this laptop here. And that's called Ecamm Live, and that helps me do a lot of that sort of very slick transitions and things like the overlays like that. They're very easy to sort of drop in there just as a little animation. So yeah, it's things like screen sharing, things like that, or be in the little corner there. Very easy to do all that kind of stuff with this software and this setup. So yeah, this is me in my happy place in my little robot lab. You can see got the overhead camera there as well, so I'm doing like little shots on the overhead, and I've also got this little portable one here that I can sort of move around and have a bit more interactive shots there. You can see a Plasma 2040 in action there on that robot head. It's got a Servo 2040 and a Plasma 2040 currently working away. Yeah, and I'll show you a bit further around actually. So I'm in the middle of just upgrading my lab at the moment, so you can see there's a little Plasma 2040. No, that's Interstate 75, isn't it, Phil? Just showing off some fancy graphics there. And that's the Galactic Unicorn, which I don't think is released yet, is it? I guess you guys are still working hard on the code.
Pending John coming back from holiday and doing a sprint on it.
Yeah, and then up here I have a sort of reference boards up here. So if I need to know what pinouts I've got for a particular board, I can quickly just grab that down and have that next to me while I'm working. There's the Billy Bass fish just in the corner there. Got some movie posters and some of the robots. So this is what I've been just upgrading, just putting some extra shelving in. There's the PieChart. Got some SMARS robots. I was wondering if that Kevin Thomas is the same Kevin Thomas that designed these SMARS robots. Not sure. And I've got some movie posters there as well. Another robot head up there. Got some other bits and pieces in there, the Magpie magazines and whatnot. And some of these boxes here are the box of shame, where some projects that have not quite made it, that's where they live. And then you can just see across there. That's where Alex sits, my moderator, went, oops, just in the corner. Oops, I'm trying to do this in reverse there. She sits in this sort of corner here. Got a little steampunk thing there. So it's only a little shed-like environment. But it's it's perfectly ideal. And once I've got the setup just right, got the right kind of lens on the cameras and everything, that just helps make everything pop, I guess. So yeah,
It's a fantastic
little tour of the studio. Yep, and all these drawers are just absolutely like jammed packed. I can show you in there while Damon's doing his stuff. So I've got all kinds of components and things in there. I've got loads of Raspberry Pi Picos, the original ones. Got all kinds of other bits and pieces as well that I've not done some projects on yet. Old Arduinos, and that's a breakout garden thing for the Pico as well. All kinds of things. So that's just one of the things I've got there. I made these nice little stands as well for these Enviro Pluses. They're really, really helpful, handy as well for sort of mounting things on. This is just a pile of stuff I'm currently working on.
Wow, nice stamps. Yeah. Well, when I clean a little bit my cave, because you have a really nice cave, I show my one.
Yes, I'd be very, very interested to see that. Got a line up there of different Smiles robots. These are the very first robots I sort of built, but these are built on the Arduino. And there's various different things. And then up here, just got boxes of components and chips and things. You see a little Pico poking out there. There's a whole bunch of ESP32s and 8266s in there, and WeMOS D1s. And then all kinds of different components and servos and things in there. And I've got a bunch of badges. Got the Tufty, got the I think 2 badges, and a bunch of other things. I've just got some new capacity there at this side to add some extra boxes full of stuff too. So there you go. That's as much as I'm willing to show you on that side. This is the sort of working area where everything is just shoved off camera. I do get sent things from companies. There was one company, Seed Studio, who sent me this. I don't think it's released yet. And it doesn't actually, it's like an edge device. I'll just grab hold of it. It's got a bunch of like sensors in there, like including a little camera module. And I think it uses LoRaWAN, but I can't get it to actually work. It's got a really nice little sort of terminal. So it's got a little screen on the front there. I think it's like an ESP32 inside. I don't know if you can't actually see.
No, it's a.
Don't try running MicroPython on it because you won't get Wi-Fi working.
Yeah.
Yeah, it's the WIO terminal. I've got one of these myself, but
yeah,
it uses a Realtek Wi-Fi chip.
Yeah. Yeah, and they sent me like some links to stuff, but I can't actually get it working. So sometimes this happens where they say, will you review our product? And then you get it and it doesn't actually work. So I'll review it when it works.
A WiiO terminal from them with the same request and nothing works.
Yeah. There you go.
Yeah, they have this thing called RGPy, so it's a different fork, slightly different again. It's it's like an Arduino coercing into MicroPython mode. So.
Yeah, I've got some ArduCam like a time of flight camera, but that doesn't. The Python drivers don't work on that, and I don't think there's any MicroPython drivers yet for that. So I normally try and just hack together from what they've done in Python, get it working on MicroPython. Usually, it's not too bad to do that, but yeah, they sort of think of that second, I guess. Yeah, I noticed before there was a keypad thing. So I know this is a Pimoroni one, isn't it? The Kibo 2040. See that? That's an RP2040 based keypad. So I guess once there's like a wireless version of that, when Bluetooth finally comes to the Pico W, that'll be quite a game changer for things like that. But until then, we just have to wait.
I have a small demo ready.